Hello friends, today we are going to discuss about the surface tension by Geiger's method. So first of all, we discuss about what is meant by surface tension and the basic concepts related to the surface tension. So here is the experiment setup of this surface tension, and surface tension means what? The tangential force per unit length of a line drawn in the liquid surface perpendicular to that line at any point and tending to pull the surface apart along a line. That is means surface tension means what? The force, this per unit length means here the force per unit length. So unit is Newton per meter or dyne per centimeter. In brief, surface tension means what? Force per unit length. Force per unit length. So in SI unit, the force is expressed in Newton and length in meter. This is the SI unit, Newton per meter. And in CGS unit, the surface tension is expressed in dyne per centimeter. So surface tension means force per unit length. So there are the two molecular forces. First is the cohesive force called as cohesion, or the cohesion force or the cohesive force or the cohesion is called as the force of attraction between molecules of the same substance. Suppose this is the water, and the force acting between the two molecules, which is the cohesive force, means the force of attraction between molecules of the same substance. Example is the force acting between two molecules of the water. Second one is the adhesive force, all called as adhesion. So adhesion means what? It is a force of attraction between molecules of the different substances. For example, force acting between molecules of water and glass. And so this is the glass molecule and this is the water molecule. So this is the force of attraction between these two is the adhesive force or the adhesion, force of attraction between molecules of the different substances. Example is water molecule and the glass molecule. So these are the two types of the molecular forces. Another one is term related to the surface tension is the molecular range. Means the maximum distance up to which the force of cohesion between the two molecules can act is called their molecular range. So in case of the solid and liquids, the molecular range is about 10 raised to minus 9 meter. This is the molecular range between solids and liquids. Another concept related to the surface tension is sphere of influence. Means the sphere drawn around the molecule with the molecule as center and radius equal to its molecular range. So this is the molecule and the sphere which is drawn around this molecule, and the molecule as a center and radius equal to this molecular range called as a sphere of influence. So these are the basic concepts related to this surface tension. Here this is the Geiger's method apparatus which is used to to determine the surface tension. So this is the principle of this Geiger's method is, so the Geiger's method works on the principle that the pressure inside the air bubble in a liquid is greater than the pressure outside it by 2T upon R. This is the principle of this Geiger's method. So here T is the surface tension of the liquid, R is the radius of this bubble. So construction of this Geiger's method, the apparatus mainly consists of this Wolff's bottle and the glass pipe A, B, C, D. This is the glass pipe, and one mouth of this glass pipe A, B, C, D, which is fitted to the one mouth of this Wolff's bottle. The other mouth is fitted with this dropping funnel. This is the dropping funnel which contains the water, and a manometer containing low density liquid is joined to this glass pipe ABCD. The end part tube of this CD is drawn into a fine capillary and this end dips 2 to 3 centimeter in the liquid, of which surface tension is to be determined. So this is about the construction. This is the Wolff's bottle having two mouths. One mouth is fitted, this is the glass pipe A, B, C, D, which is fitted to this one mouth of this Wolff's bottle. This is the dropping funnel containing water. This dropping funnel has the stopcock and the manometer M having low density liquid connected to this glass pipe ABCD, and the end part of this glass pipe which is dipped in the liquid about 2 to 3 centimeter. This is the experimental liquid of which the surface tension is to be determined. Actually, in working, as the liquid rises into this capillary tube CD, due to the capillary action and the meniscus is nearly spherical. This is the air bubble. When water from the dropping funnel is allowed to slowly enter into the Wolff's bottle, an equal amount of air rushes in this tube ABCD. The liquid in the tube goes down slowly and forms a bubble at the end. The radius of this bubble gradually decreases with increasing pressure inside it. It attains a semi-spherical shape of radius r equal to that of the end capital D of this capillary tube. The difference H, this is the difference H in the levels of the two arms. These are the two arms of this manometer is noted. The bubble becomes unstable as the water comes in this Wolf's bottle. An equal amount of air rushes in this glass tube ABCD, and some part of the air goes to this at the end CD, and some part of the air comes to this manometer. So there is a difference between the two manometer arms, and this difference indicates the H. So the difference H in the levels in the two arms of the manometer which is maximum and which is to be noted, and the bubble becomes unstable and finally it breaks. The radius R of the opening end capital D of this capillary is found out by the microscope. Here rho is the density of this manometric liquid. Rho is the density of this manometric liquid, and P is the atmospheric pressure, and this is the sigma, which is the density of this experimental liquid. Small d, this is the depth of the free end of this capillary below the free surface of the liquid. Then the pressure outside the bubble just before it breaks, which is P plus sigma dg, is the pressure before it breaks, P plus sigma d into the g, and the expressed pressure inside the bubble, which is the difference between P plus h rho g when you take the excess pressure inside the bubble, means the difference between these two, which is equal to G into the H rho minus sigma d. So if this capital T is the surface tension of the liquid, then the excess pressure inside the air bubble is 2T upon R. Here T is the surface tension, R is the radius of this bubble, and so 2T upon R is the excess pressure inside the air bubble, T is the surface tension of the liquid, R is the radius of the opening end of this capillary D. So 2T upon R equal to G into H rho minus sigma d. H is the difference between these two arms of this manometer, G is the acceleration due to gravity. Rho is the density of this low density liquid which is in the manometer. Sigma is the density of this experimental liquid of which the surface tension to be determined. D is the depth of free end of the capillary below the free surface of this liquid. So by solving this equation, this is 2T upon R equal to G into H rho minus sigma D. Here T is the surface tension, R is the radius of this capillary tube, at D this radius can be determined by using the microscope. So the G is the acceleration due to gravity, H is the difference between the two arms of this manometer, rho is the density of this low density liquid which is in the manometer, sigma is the experimental liquid of which surface tension is to be determined, and D is the depth of this capillary which is below the liquid. So by solving this equation we get rearrange this equation. So T is equal to, take the R to the right hand side, so T equal to Rg by 2 into H rho minus sigma D. By knowing the H and D, H is the difference between the two arms of this manometer and D is the depth of this capillary below the liquid. So by knowing the values of H, D and R, we can determine the surface tension of the given liquid by using the Geiger's method. So this is the simple method to determine surface tension. So this apparatus consists of this Wolf's bottle, this is the dropping funnel, this is the glass pipe A, B, C, D, this is the manometer having the two arms, and the Wolf's bottle have the two mouths. To the one mouth the glass pipe ABCD is connected and other mouth is connected to the dropping funnel which is containing the water. This dropping funnel have the stopcock. When an equal amount of the liquid water comes into this Wolf's bottle, then that amount of air rushes to this some part of the manometer and some part to the this end part D. So surface tension of the liquid can be determined by using Geiger's method by using the formula T is equal to Rg by 2 H rho minus sigma D. So the Geiger's method, by using the Geiger's method, the surface tension can be determined using the formula T is equal to Rg by 2 into H rho minus sigma D. Here T is the surface tension, R is the radius of this end part of this capillary tube. G is the acceleration due to gravity. H is the difference between the two arms. Rho is the density of this low density liquid which is used in the manometer. Sigma is the density of the experimental liquid of which surface tension is to be determined, and D is the depth below this liquid. So this is the surface tension by the Zeise's method. So thank you.